In the cold silence of space, suspended in the eternal darkness 5 million kilometers from Earth, there floats a golden eye, patient, unblinking, and eternal. The James Webb Space Telescope, humanity's most ambitious window into the cosmos, stares into the infinite night, chasing light that has been traveling since the dawn of everything. It is more than a machine, it is a testament to the human spirit, a cathedral of science and soul, built not of stone, but of mirrors, math, and dreams. When we first sent Webb into the void, we didn't just launch a telescope. We launched hope. We launched a question. We launched humanity's deepest yearning to see where it all began. For thousands of years, we have looked up at the stars and wondered, where did it all come from? Where are we going? What is our place in all of this? Every generation before us saw only fragments, tiny glimmers in the dark. But this golden eye was built to see beyond the veil, to look back, not just in distance, but in time itself. Because that is the strange and wondrous thing about light. When we look into the night sky, we're not seeing stars as they are now, we're seeing them as they were. The farther we look, the older the light becomes. Look at the sun, and you see it as it was 8 minutes ago. Look at the nearest star, and you see it as it was 4 years ago. But Webb looks so deep that it sees billions of years into the past, all the way to the moment when the first stars ignited in a universe still fresh from the birth of time. To understand how extraordinary that is, imagine trying to see your own childhood by staring into a mirror that bends reality. That's what Webb does. It peers through the cosmic fog, across the eons, into an era when galaxies were just beginning to form. It's not just a telescope, it's a time machine. It doesn't photograph the present, it resurrects the ancient past. But to reach that far, to hold that much truth, Webb had to be unlike anything ever built. Its mirror gleaming, hexagonal gold, coated stretches over 6.5 meters wide, designed to capture the faintest whispers of ancient light. Its sensors are so sensitive they could detect the heat of a single candle on the moon. And to protect it from the sun's glare, it carries a massive sunshield the size of a tennis court, 5 delicate layers thinner than a human hair, each one keeping it cold enough to see the invisible, because to see the early universe, you must see in infrared, the light stretched by time itself as the universe expanded. Only in that soft, ancient glow could Webb find what Hubble never could. And so, on December 25, 2021, as millions around the world celebrated the birth of a savior, humanity launched its greatest eye to search for the birth of everything else. From a spaceport in French Guiana, the rocket lifted into the dawn, carrying with it more than just metal and circuitry. It carried 20 years of human labor, 10,000 scientists and engineers, and the fragile hope that it would survive the impossible. Every bolt, every cable, every golden plate was the product of human faith. Faith not in gods, but in knowledge, in courage, in curiosity. The days that followed were filled with tension. Webb had to unfold itself in the vacuum of space like a blooming flower, piece by delicate piece. One wrong move, one frozen gear, one torn sunshield, and decades of work would vanish into nothing. But like a patient guardian, it unfolded perfectly. Its mirrors blossomed, its shield stretched open, its instruments came alive. And when it reached its destination, the L2 Lagrange point, where the pull of Earth and Sun balance perfectly, it became still, silent, waiting, and then it began to see. The first images were beyond comprehension. Thousands of galaxies, each a world of billions of stars, filled a tiny patch of sky no larger than a grain of sand held at arm's length. Every dot, every smear of light was a galaxy, some so distant that their light had left them when the universe was still a child. It was as if Webb had peeled back the skin of time and shown us creation's first heartbeat. Humanity collectively gasped. For the first time, we were looking not at what the universe is, but what it was. But the beauty of Webb's gaze isn't just in what it sees. It's in what it means. Because every photon that strikes its mirrors is ancient, a messenger that has traveled for billions of years across the vacuum, untouched, unbent, until it meets that golden surface. When that light enters Webb, it carries with it the story of beginnings, the birth of galaxies, the dance of cosmic dust, the flicker of the first stars ever born. Webb doesn't just see light, it listens to time. It decodes the language of eternity, and what it found shocked even the most brilliant minds. Galaxies that shouldn't exist so soon after the Big Bang, structures that defied the timeline of creation. Stars that burned too brightly, too early. In that moment, our models trembled. The universe, it seemed, was in more of a hurry to exist than we ever imagined. It was as though, in the first moments after time began, creation was impatient, rushing to shape beauty out of chaos. But what makes this discovery so deeply human is not just the science, it's the symbolism. Think about it, here we are, a fragile species on a small blue planet orbiting a mediocre star, daring to build a machine that can see to the edge of everything. We took atoms from the Earth, gold, silicon, beryllium, and arranged them with such precision that they could touch the light of the first dawn. The same elements, forged in the hearts of stars, were now being used to look back at their ancestors. The universe made us, and now we made something to look back at it. That's not science, that's poetry. Every photon Webb collects is a memory, a snapshot from a time when the cosmos was young, and every one of those memories whispers the same thing: you are part of this. Because when we look deep enough into space, we're not just seeing galaxies, we're seeing ourselves. The atoms in your blood, your bones, your breath, they were all once part of a star that lived and died billions of years ago. The light Webb captures is the same light that once gave birth to you. In a very real way, when Webb looks into the beginning of time, it's looking into the beginning of us. But the power of Webb goes beyond discovery, it transforms perspective. It makes you realize how small our worries truly are. The things that consume our days, anger, fear, division, shrink to nothing when you remember that we are floating in the middle of infinity. Webb reminds us that we are a species of explorers, dreamers, builders, capable of extraordinary things when we chase wonder instead of war. When you see those golden mirrors reflecting starlight older than Earth itself, you realize what humanity can do when we believe in something bigger than ourselves. Webb wasn't built by one nation, it was built by a collaboration of minds from across the planet, scientists from NASA, ESA, and CSA working as one. People who spoke different languages but shared the same dream. The telescope isn't just a triumph of technology, it's a symbol of unity. Proof that when humanity looks up together, the impossible becomes possible, and yet, there's something profoundly emotional about the silence of that machine. It has no voice, no pulse, no mind, and yet it carries the weight of all human curiosity. It stares into the void and sends back light that was born before there were humans, before there were planets, before there was even dust. Light from a time when the universe was nothing but energy and possibility. To think that a machine we built could hold such ancient truth in its sensors, it humbles you. It makes you realize how fragile we are, and yet how infinite our reach can be. Each new image Webb sends is a chapter from a cosmic story older than language. Nebulae that look like stained glass cathedrals, galaxies colliding like dancers, stars being born in clouds of fire and dust. These are not just pictures, they are revelations. They are reminders that creation is still happening, everywhere, always. The universe is not a finished masterpiece. It's a living, breathing work in progress, painting itself in light across billions of years. And what's most haunting, what chills you to your core, is that Webb is looking at things that no human will ever touch. The galaxies it sees are so far away that even if we traveled at the speed of light, we'd never reach them. Their light is ancient, their worlds long gone. Some of those galaxies may not even exist anymore. We're seeing their ghosts, their echoes frozen in time. Webb shows us that the universe is a place where even death has beauty, where the past still glows, where nothing truly disappears, it just drifts into memory. But even as it looks outward, Webb turns our gaze inward. It makes us ask the questions that matter. Why are we here? How did all of this come to be? And how, in a universe so vast, did consciousness arise? This strange, fragile ability to wonder. Maybe the universe built us just to see itself. Maybe every star Webb captures, every spark of light, is part of a grand design, a design that needed eyes to appreciate its beauty. And maybe, just maybe, that's our purpose, to witness, to wonder, to remember. As Webb continues its journey, orbiting silently around the Sun, it keeps sending home treasures, images of the distant past, data that will rewrite the story of creation. But even if the science changes, the message will remain the same. Curiosity is the highest form of courage. To look into the unknown and still reach forward, that is what makes us human. Think of it, one telescope, a delicate machine of mirrors and light, now holds the power to show us the universe as it was before time even had a name. It's as though we built a bridge between now and forever, a way to touch the first light that ever existed. Every time Webb opens its golden eye, the universe whispers secrets we've been waiting billions of years to hear. And when we stand beneath the night sky now, knowing that our creation is out there, seeing deeper, farther, older than anything ever has, we can feel it. That small, humbling truth, we are the universe looking back at itself. We are the children of stardust, teaching our cosmic ancestors to be seen. So yes, when James Webb looked too deep into space, what it found was shocking. It found that time has memory. That light never forgets that the universe, vast and ancient as it is, still carries the fingerprints of its own birth. But most of all, it found something extraordinary, that in the act of looking, humanity discovered itself. Because to look beyond time is not just to see the beginning of the universe, it's to remember that we were always a part of it. We always will be. When James Webb opened its golden eyes and began sending back the first images of the distant universe, scientists prepared themselves for beauty, but not for disbelief. They expected to see faint smudges of light, fragile hints of the first galaxies still taking shape in the cosmic dawn. What they did not expect was to see the universe already grown, fully formed galaxies, vast, spiraled, brilliant, appearing impossibly soon after the Big Bang. It was as if Webb had peered back to the very beginning and instead of chaos found maturity, instead of infancy found adulthood. And that, more than anything else, shook the very foundation of cosmology. For decades, astrophysicists believed they understood how the universe evolved. According to the Standard Model, it all began roughly 8 billion years ago, a blinding explosion of energy and matter. In those first moments, the universe was dense and hot, filled with a sea of particles and radiation. Only after hundreds of thousands of years did it cool enough for atoms to form. Only after millions more did gravity start pulling hydrogen and helium together, giving birth to the first stars. And only after hundreds of millions of years, through cycles of birth, death, and explosion, could galaxies begin to emerge. That was the timeline, that was the theory, that was the story we told ourselves about how order rose from nothingness. But then Webb looked deeper, deeper than any telescope in history, and the story began to unravel. One of Webb's early targets was a patch of sky called Sears, the Cosmic Evolution Early Release Science Survey. In that region, the telescope saw what appeared to be a handful of distant galaxies, their light stretched red by billions of years of travel. Scientists ran the data, measured the light, and then fell silent. What they found didn't fit. These galaxies were far too bright, far too massive, far too evolved to have formed so soon after the Big Bang. Some appeared to exist just 300 million years after time itself began, and yet they looked as though they had already lived for billions of years. It was impossible, it was magnificent, it was terrifying. One particular object, labeled Sears 93316, stood out like a cosmic paradox. Webb's instruments detected its light coming from just 235 million years after the Big Bang. To put that in perspective, if the universe's entire history were compressed into a single year, Webb was seeing galaxies that existed before January had even ended.
The James Webb Space
According
Telescope's
to our models,
detection of water
there shouldn't
vapor
have
in
been
the
enough
atmosphere
time
of an
for
exoplanet
galaxies to
only
form,
26
for stars to
years away
burn,
belongs
for
to
matter
this
to
category
gather
of
and organize
world-changing
itself
milestones.
into something
To
so
call it
grand.
historic is not an
And yet,
exaggeration.
there they were,
It is the
glowing,
continuation
ancient,
of a legacy
defying
of human
everything.
curiosity,
Scientists
stretching from the
called
first
them
time ancient
impossible
people
galaxies,
looked at the night sky
and for
to the
good
moment
reason.
scientists launched
Their
JWST
existence
into
broke
orbit.
the laws we
This
thought
discovery
governed
is not
cosmic
just about
evolution.
data on a screen.
These
It
galaxies
is about our
weren't
identity
small
as
clusters of
explorers, our
stars
destiny
still
as
learning to
seekers.
assemble. They were massive, structured, with complex chemistry and abundant starlight. Some even showed signs of spiral shapes, suggesting rotation and order. That's like discovering a full-grown forest where only seeds should exist. When the data first arrived, some researchers thought it had to be a mistake. Maybe the instruments were misreading the light. Maybe what Webb saw wasn't as far away as it seemed. Maybe there was some trick of dust or gravity bending the signal. But as the analyses grew more refined, the truth became harder to deny. These galaxies were that old. They did exist that early, and they were rewriting the cosmic timeline. In science, there are moments that change everything, moments when data refuses to obey expectation, when reality steps beyond the edges of the map. That's what Webb gave us, a universe that is older, faster, and more ambitious than we ever imagined. Because if galaxies formed this early, then the first stars must have ignited almost immediately after the Big Bang, within tens of millions of years, not hundreds. That would mean the universe wasted no time at all. It was not a patient artist, it was a furious creator, sculpting light from chaos with unimaginable speed. And yet, there's a deeper mystery hidden in that revelation, a question that reaches beyond science into philosophy itself. Why does the universe hurry? Why did it rush to build structure so soon? What if the cosmos isn't a slow, unfolding story, but a restless symphony, one that seeks beauty and balance from its very first note? What if creation itself is impatient? Astronomers began rethinking everything from dark matter, which may have accelerated the growth of galaxies, to gravity, which may have behaved differently in those early times. Some even proposed that the Big Bang might not have been the true beginning, but merely the latest phase in a longer, cyclical universe, a universe older and more complex than our equations can yet describe. Others wondered if our understanding of cosmic expansion, the redshift we use to measure distance and age, might need to be redefined. Webb didn't just show us new images, it challenged the meaning of time itself. And yet, amid all this scientific turmoil, there is a quiet poetry in what Webb revealed. Imagine those first galaxies, blazing islands of light in an endless sea of darkness. There were no planets yet, no observers, no names. Just light, pure, defiant light, breaking through the void. Each galaxy was a miracle of balance, gravity pulling inward, radiation pushing outward, creation and destruction dancing in perfect harmony. And for billions of years, their light traveled silently through space, across cosmic storms, through the birth of stars and death of worlds, until it finally reached us. We are witnessing their ancient glow not as they are, but as they were, as they existed before our sun, before our earth, before life itself. Every time Webb captures an image, it captures a message from the beginning of time. That light has traveled across eternity to find us. It carries with it the memory of creation, the proof that even in the universe's first breath, there was already complexity, already beauty, already story. That's what makes these impossible galaxies so haunting. They're not just anomalies in data, they are echoes of a universe that has always been more capable than we imagined. Think about it. Those galaxies Webb sees are not just far away in space, they're far away in time. Their light began its journey when the universe was young, long before the Milky Way existed, and yet, somehow, that light found us. In a sense, it always would, because the moment that light was born, it was destined to end up here, on a tiny blue world orbiting an average star, in the eyes of beings who would one day learn to wonder. The universe, in all its chaos, seems to have written us into its script. For scientists, though, the paradox remains. If galaxies formed so early, how did they grow so massive? What force gathered so much matter so quickly? Did dark matter, the invisible scaffolding of the cosmos, play a greater role than we thought, or could there be an unknown form of physics at play, something beyond our equations? Every new Webb discovery seems to open more questions than it answers, but that's the beauty of exploration. Every time we expand the horizon, the mystery deepens. And yet, in that mystery lies the proof of progress. For every galaxy Webb sees, we're forced to rethink our models, our theories, even our definitions of what's possible. Science doesn't collapse under contradiction, it grows. The fact that these galaxies exist doesn't break the universe, it expands our understanding of it. It reminds us that knowledge isn't a destination, it's an evolution. Webb's shocking discovery isn't a problem to solve, it's an invitation to dream bigger. When you look at those deep field images, filled with thousands of glowing spirals and red smears, you realize that each of them is a story billions of years old. Each of them contains billions of stars, millions of worlds, perhaps even life. And yet they all fit in a single frame, a fraction of the sky no larger than a grain of sand held at arm's length. Imagine what that means for the rest of the cosmos. If there are thousands of galaxies in that tiny dot of darkness, then there are trillions across the sky. Webb isn't just showing us where the universe began, it's showing us how infinite it truly is. But the human heart can't help but find meaning in that infinity. The galaxies Webb discovered are more than scientific curiosities. They are metaphors for resilience. They represent the universe's refusal to stay simple, its relentless drive toward complexity and creation. Against all odds, in the chaos of its infancy, the cosmos found a way to build structure, to build light. Just as humanity, in its own infancy, found a way to build understanding from confusion, the early universe, in a way, mirrors us, restless, ambitious, creative beyond reason. When you imagine those impossible galaxies, imagine them not as distant strangers, but as ancestors. Because, in a sense, they are. The atoms in our bodies were once forged in the stars that filled those ancient systems. Their light became our story, their matter became our form. They are the first chapters of the book that eventually wrote us into existence. The universe began with them, and through them it began to dream, and so, when James Webb looked too deep into space, what it found wasn't just shocking, it was humbling. It found proof that creation moves faster than comprehension, that beauty appears before logic can explain it. It found galaxies that shouldn't exist, and yet do, just as humanity shouldn't exist, and yet does. It's a reminder that the impossible is not a barrier, but a beginning. The galaxies that Webb sees are time capsules, frozen moments from an era before life, before memory, before meaning, and yet here we are giving them meaning. Their light is older than our planet, older than our species, older than our dreams, and yet it illuminates our understanding today. That's the poetry of science, the past shaping the present through the language of light. Perhaps that's the universe's secret. Perhaps the reason those galaxies exist when they shouldn't is because creation itself refuses to wait. Maybe the cosmos, like us, is impatient to be seen, to be known, to be loved. Maybe that's why in every corner of the sky there's light ancient, persistent, eternal, trying to tell us that it was always here, waiting for eyes to notice. So the next time you look up at the night sky, remember this: some of the stars you see are gone, their light only now arriving. Some of the galaxies that Webb photographs no longer exist, yet their glow still travels across the void. Nothing truly disappears, not light, not wonder, not the desire to understand. Webb's discovery of galaxies that shouldn't exist is not the end of a mystery, it's the start of a deeper one. It's a reminder that the universe does not answer to our expectations. It reveals itself on its own terms. And maybe that's the most shocking truth of all, that the universe is always one step ahead of us. That just when we think we've reached the edge, we realize there's no edge at all. There's only depth, only wonder, only the endless journey of light coming home. Because in the end, every time James Webb looks too deep into space, it's really looking into a mirror, showing us not just where the universe came from, but what we're capable of understanding. These galaxies that shouldn't exist are not mistakes in the cosmic script. They are evidence that the story is bigger than we ever believed. And the deeper we look, the more we'll realize the universe has been waiting for us to see its true self. It always has. When James Webb turned its golden gaze toward the earliest galaxies, it expected to see simplicity, pure hydrogen and helium, the first ingredients of creation. Those were the only elements born from the Big Bang, forged in the first minutes of cosmic existence. Everything heavier, carbon, oxygen, nitrogen, iron, gold, all of it was supposed to come later, built in the hearts of stars that lived, burned, and died over countless generations. The early universe, scientists believed, was supposed to be chemically barren, a simple soup of primordial gases. But when Webb began decoding the light of those ancient galaxies, something astonishing appeared. The chemical fingerprints of heavy elements, elements that shouldn't exist yet, began to reveal themselves. The universe was already filled with complex material. Somehow, in a blink of cosmic time, the elements of life had arrived far earlier than anyone ever imagined. To understand why that's shocking, we have to return to the beginning, to the moment after the Big Bang. In that first flash, the universe was nothing but energy, dense and blinding, expanding at speeds beyond comprehension. As it cooled, protons and neutrons began to form, merging to create the simplest atomic nuclei, hydrogen and helium, with traces of lithium. That was all. For millions of years, the universe was dark, a fog of neutral gas, silent and invisible. Then gravity began to pull matter together. In small pockets, hydrogen clouds collapsed under their own weight, heating up until the first stars ignited. These were the population Roman 3 stars, the universe's first generation of light. But these weren't stars like our sun. They were titans hundreds of times more massive, burning millions of times brighter. They lived fast, burned violently, and died young. In their fiery cores, the first heavy elements were born. Fusion transformed hydrogen into helium, helium into carbon, oxygen, silicon, and beyond. When these colossal stars finally died, they didn't fade quietly. They exploded as supernova, scattering their newly forged elements into the cosmos. Those explosions were the universe's first act of recycling, spreading the seeds that would one day build everything we know. Every rock, every ocean, every tree, every heartbeat, all of it began as stardust flung into the dark by those ancient giants. Scientists believed this process took time, hundreds of millions of years of stellar births and deaths before enough heavy elements could accumulate to form the first complex galaxies. But Webb's infrared eyes told a different story. In galaxies that existed barely 300 million years after the Big Bang, it detected oxygen, carbon, and even traces of iron, elements that should have taken far longer to appear. It was as if the universe had skipped steps, accelerating its own evolution. The first time astronomers saw those chemical lines in Webb's data, they were stunned. The spectra, the fingerprints of light, showed patterns far richer than expected. The universe, so young, was already busy with life's ingredients. In cosmic terms, that's like discovering an oak tree already bearing fruit moments after the seed was planted. It meant that the first stars had lived and died faster, more violently than anyone had imagined. The cosmos wasn't patient, it was urgent. Creation was in a hurry, the implications were profound. If these heavy elements existed so early, it meant the first stars were far more massive than our models predicted, so massive that they could live for only a few million years before collapsing. It also meant those stars must have exploded with unimaginable energy, seeding the universe in record time. Webb was showing us a universe far more dynamic and restless than the one we had dreamed of, and yet within that chaos there was artistry. The presence of those early elements wasn't just a chemical surprise, it was a whisper of destiny, because those same elements would become the building blocks of planets, oceans, and eventually life. Oxygen would fill the skies of future worlds, carbon would form the backbone of every living cell, iron would flow through the blood of creatures yet to exist. Every atom Webb detected in that ancient light was a promise, a message from the past saying, life will come. It's humbling to realize that the story of existence is written in chemistry. The iron in your blood, the calcium in your bones, the oxygen in your breath, all of it was forged in the hearts of ancient stars. Every heartbeat you feel is powered by the ashes of a supernova. Webb's discovery reminded us of that truth in the most profound way possible. The universe built the ingredients for life almost as soon as it could. Creation wasted no time giving birth to possibility, but beyond the poetry there lies a mystery that still unsettles the scientific mind. How could so much chemical complexity exist so early? If these heavy elements formed from the first stars, then the first generation must have been born almost immediately after the Big Bang, far sooner than models allow. Did gravity act differently back then? Was dark matter, that unseen scaffolding of the cosmos, helping to compress matter faster than expected? Or was there another, unknown mechanism driving creation forward? Some researchers began to suggest that the laws of physics, as we know them, might not apply in the same way at those extreme cosmic epochs. Perhaps the universe had more tools in its arsenal than we understand, processes we haven't yet discovered, forms of matter or energy that accelerate creation. Others proposed that Webb's discoveries might hint at a multiverse, that our universe is just one bubble in a vast cosmic sea, each with its own timeline of formation. The possibilities multiplied like stars themselves, but even if the science is still uncertain, the awe is undeniable. Imagine those first stars, blazing blue giants, enormous and short-lived, burning their fuel with ferocity. They lived for mere millions of years, but in that time they created the foundations of everything. When they died, they scattered carbon into the void, the carbon that would one day become the molecules of love and thought. They scattered oxygen, the breath of worlds yet unborn. They scattered iron, the pulse of life that would flow in veins and rivers alike. These were not just stars, they were creators. They were the universe learning how to make itself rich and diverse. And Webb's infrared eyes caught their fingerprints still glowing across eternity. In the soft red light Webb captured, we're not just seeing stars. We're seeing the ancestors of our own chemistry, the cosmic alchemy that made consciousness possible. We often speak of the Big Bang as the birth of the universe, but in truth, it was only the birth of potential. The real creation, the transformation from energy to matter, from simplicity to complexity, began with those early stars. They are the missing link between the fire of creation and the breath of life, and Webb, with its perfect mirrors, has finally found their trace. When you look at one of Webb's deep field images, full of glowing galaxies and distant light, you might think you're looking at something far away. But in a deeper sense, you're looking inward into the elements that built you. Every pixel, every shimmer of distant light, contains the story of your own atom's journey across time. The oxygen you breathe today once danced in the core of a star web has now seen. The iron in your blood once fused in a stellar furnace that exploded long before Earth was born. The calcium in your bones, the nitrogen in your DNA, all of it began out there, in those impossible early galaxies. We are, quite literally, the universe remembering itself, and perhaps that's why Webb's discovery feels so intimate. It's not just about understanding the cosmos, it's about understanding ourselves. When we see heavy elements appear far earlier than expected, we're seeing the fingerprints of our own origin written into the first light. The universe was preparing for us from the beginning, shaping the raw materials of existence with breathtaking speed. It's as though creation itself couldn't wait to become aware, couldn't wait to see, to feel, to love. The data from Webb continues to pour in, each observation revealing new surprises. Galaxies once thought too young now sparkle with rich chemical diversity. Astronomers find traces of dust, cosmic ash made from dying stars, swirling in places that should still be empty. In every direction Webb looks, it finds evidence that the early universe was already alive with transformation. The cosmos was not static, it was creative, it was wild, it was eager, and yet the more we learn, the more mysterious it becomes. If heavy elements formed so quickly, perhaps our understanding of time itself needs revision. The early universe may have evolved differently, with pockets of rapid growth, bursts of creation that defy smooth, linear logic. Perhaps there were regions where matter condensed faster, where stars lived brief, brilliant lives before vanishing. Webb is forcing us to see the universe not as a calm unfolding, but as a chaotic symphony, a universe alive with urgency. But amid all the data and theories, there's a deeper truth that transcends science. Webb's discovery of ancient elements is a reminder that the universe doesn't just expand in size, it expands in meaning. From nothing came hydrogen, from hydrogen came stars, from stars came oxygen, carbon, and iron, from those came oceans, worlds, and life. And from life came eyes capable of looking back and asking why. That's the circle Webb completes, the universe creating beings who can witness the miracle of their own creation. It's almost poetic that the same telescope built from those very elements, from gold, silicon, and iron, is now uncovering their cosmic birthplace. The universe created matter, matter created life, life created consciousness, and consciousness built a telescope to look back at the beginning. In a way, Webb is the universe remembering its own youth. The mirror reflects both outward and inward. When it gazes into ancient light, it also gazes into our own origin story, the chemistry that dreamed itself awake. So when we say Webb found heavy elements that shouldn't exist, what we really mean is that Webb found us, our raw ingredients, our ancestors, our beginning. The carbon in our veins was already alive in that ancient light. The oxygen that fills our lungs was already forged when the universe was barely out of infancy. That's not just shocking, it's sacred. It means that even in the universe's first breath, the potential for love, art, and thought was already there, written in the fabric of atoms. Perhaps that's the greatest revelation of all. The universe is not a cold, indifferent place. It is a creative force, impatient to become more. It doesn't wait billions of years to form beauty, it rushes toward it. It builds, it burns, it transforms. It is both the artist and the art. And through Webb, we are finally seeing that creativity unfold in real time, the proof that the cosmos has always been alive with intention, even before there were eyes to see it. When you look at one of Webb's images, remember, you're not just seeing light. You're seeing time, chemistry, and destiny intertwined. You're seeing the moment when the elements of existence were born. You're seeing the ashes of stars that became the dust of Earth, the soil beneath your feet, the breath in your chest. Webb is showing us that the universe has always been a forge, and that we are its most recent creation. The discovery of ancient elements isn't just a scientific shock, it's a spiritual reminder. The universe became rich far sooner than we thought. It became capable of creating life before it even knew what life was. And somewhere in that early fire, the first atoms of everything that matters, everything that feels, loves, and dreams, began their journey toward becoming us. So yes, when James Webb looked too deep into space, it found something shocking. It found a universe that creates faster than we can comprehend, and a truth older than time itself, that even in the earliest light, the story of life had already begun. When James Webb looked deeper into the universe than any human-made eye before it, it wasn't just peering into light, it was peering into time itself, into the first chapters of creation, where everything we know was still in the process of becoming. Scientists expected to find young galaxies fragile, forming, still taking their first breaths in a newborn cosmos. What they didn't expect to find was darkness, vast, ancient darkness already thriving at the dawn of time. Because hidden within that ancient light were black holes so enormous, so incomprehensibly massive, that their very existence defied everything we thought we knew about how the universe grows. These were not ordinary black holes, not the kind born from dying stars, the ones scattered through the galaxies we know today. These were supermassive black holes, billions of times more massive than our Sun, existing less than 500 million years after the Big Bang. That's not enough time, by any known physics, for such cosmic giants to form. Their presence is a paradox, a riddle carved in starlight, a contradiction that shakes the foundation of cosmology itself. To understand why Webb's discovery is so shocking, you have to understand what a black hole truly is. It's not merely a place in space, it's an event, a singularity of gravity where matter collapses into infinite density, where time slows to a crawl, and light itself cannot escape. It's the ultimate end of matter, the point where physics breaks down. Black holes are born when massive stars run out of fuel and die, collapsing under their own weight. Over billions of years, they can grow by feeding on surrounding matter or merging with other black holes. That process takes time, an immense amount of it, yet Webb found monsters that had already grown unimaginably huge when the universe was still an infant. Imagine this, the universe is just a few 100 million years old, a flicker of time in cosmic terms, yet there, in the light Webb captured, are galaxies with cores so bright they outshine everything around them. That brightness isn't from stars, it's from the accretion disks of matter spiraling into black holes. As gas and dust fall toward these cosmic abysses, they heat up, glowing with the intensity of 1 trillion suns. The light travels for over 13 billion years before reaching Webb's mirrors, and when it does, it carries a message. Massive black holes were already alive and powerful at the dawn of time. For decades, astronomers believed the first black holes were born from the deaths of the earliest stars, massive, short-lived giants that exploded as supernova, leaving behind cores a few dozen times the mass of the Sun, those small black holes would then, over eons, merge and feed, slowly growing into the supermassive ones that sit at the centers of modern galaxies. But Webb's discoveries shattered that timeline. The black holes it found were too big, too soon. There hadn't been enough time for them to grow naturally. Something else must have happened, something the universe did that we still don't understand. Some scientists call it the direct collapse hypothesis. According to this idea, in the very early universe, clouds of pristine hydrogen gas, untouched by heavy elements, might have collapsed directly into black holes without forming stars first. These seed black holes could start out with masses thousands of times greater than typical stellar remnants, giving them a head start in the cosmic race. If this theory is true, it means the first black holes didn't just come from the deaths of stars, they came from the universe's raw fabric itself. They were born straight from the collapse of creation. Others suggest that black holes might have formed from dense clusters of early stars, merging in violent bursts, collapsing under gravity's grip. Or maybe, and this is the most mysterious idea of all, black holes have existed since before the first stars, as primordial black holes, formed directly from fluctuations in the infant universe's energy field only moments after the Big Bang itself. If so, then black holes may not be the result of the universe, they might be part of what shaped it. Whatever the origin, Webb's data makes one thing certain: the universe's story of creation is far more complex and dramatic than we imagined. It's as if, in the earliest pages of time, creation didn't just give birth to light, it also gave birth to shadows. What's haunting about these discoveries is the way they rewrite our understanding of cosmic balance. In the heart of nearly every galaxy, including our own Milky Way, lies a supermassive black hole. They are not destroyers,
The
they are
James Webb
architects.
Space
Their
Telescope's
gravity
detection
sculpts
of water
galaxies,
vapor in the
guiding the dance
atmosphere
of
of an
stars and
exoplanet
gas.
only 26
Without
light
them, galaxies
years
might
away
not even
belongs to this
exist.
category
But how
of
could such colossal
world-changing
forces
milestone.
emerge so early?
To call it historic
Webb's
is not
images
an
suggest
exaggeration.
that black holes
It is the
didn't just grow
continuation
with
of a legacy
galaxies.
of human
They may have
curiosity,
come first,
stretching from the
acting
first
as
time
gravitational
ancient people looked
anchors
at the night
around
sky
which
to
galaxies
the moment
formed.
scientists launched
That turns the
JWST
old
into
story
orbit.
upside down.
This
For
discovery is
decades,
not just
we
about
believed
data on a
galaxies
screen.
birthed black
It
holes.
is about our identity
Now
as
it may be the
explorers, our
opposite.
destiny
Black
as seekers.
holes birthed galaxies. That's the real shock. These monsters of gravity may have been the first engines of creation. Webb's instruments, sensitive to infrared light, see the faint glow of distant quasars, the blazing cores of ancient galaxies powered by feeding black holes. Their light tells us not only how bright they are, but what they're made of. When scientists analyzed that light, they found heavy elements, complex dust, and astonishingly mature structures, signs of rapid evolution. The galaxies surrounding these black holes weren't primitive. They were already rich, already organized. Somehow, in just a few 100 million years, the universe had built structures that should have taken billions. It was as if cosmic time itself had bent around these objects, accelerating creation wherever they appeared. And perhaps that's not far from the truth. Black holes bend space and time, not just locally, but cosmically. They warp the very geometry of reality. When matter falls into them, it doesn't simply vanish, it stretches the boundaries of existence. Some physicists believe that the energy released near black holes might trigger star formation or even shape the large-scale structure of the cosmos. If black holes formed early, they might have been the universe's first architects, building galaxies from the inside out. But Webb's discoveries raise deeper questions, not just scientific, but existential. What are black holes, really? Are they the end of matter or the beginning of something else, inside their event horizons, where gravity crushes everything into an infinitesimal point, the known laws of physics collapse? General relativity and quantum mechanics, our two greatest theories, stop agreeing. Black holes are the universe's way of telling us, you don't know everything yet. They are boundaries between the known and the infinite, and Webb has shown that those boundaries appeared almost immediately after time began. There's something deeply poetic in that. The moment the universe was born in light, it also created darkness. In the same breath that it expanded outward, it also folded inward, light and shadow, creation and destruction, born together, inseparable. The black holes Webb found are not just anomalies, they are cosmic yin to the universe's yang. They remind us that every act of creation comes with mystery, that every beginning carries its own end. When you think of the word black hole, you might imagine emptiness, an endless void, but in truth, a black hole is full of motion. Matter swirls, energy flares, space twists. It is chaos and beauty bound together by gravity. When Webb's mirrors capture the faint red light of a quasar shining from the edge of time, they are seeing that dance, the light of matter screaming as it falls toward oblivion, transformed in brilliance before it disappears. Those photons have traveled for over 13 billion years just to tell us their story before vanishing into our eyes. And in that light lies the greatest irony of all. The darkest places in the universe are also the brightest. Every time Webb peers deeper, it finds another paradox. The more darkness it sees, the more light it reveals. The more distant the object, the more it tells us about our own beginning. These ancient black holes, these cosmic leviathans, are like mirrors held up to existence itself. They show us the limits of our understanding, the edges of our reason. They show us that creation is not a straight line, but a spiral, one that curves back upon itself, where beginnings and endings merge into one. It's not hard to imagine the awe that must have filled the scientists' hearts when the data first came through. The Webb telescope, orbiting far from Earth in the cold silence of space, sent back the faint signal of a quasar, are so distant that its light left when the universe was only a few 100 million years old. In that faint red whisper of light was a truth that defied every theory they had built. They expected simplicity and found complexity. They expected smallness and found enormity. They expected beginnings and found something ancient staring back at them. Somewhere in those early days of creation, a black hole formed so massive, so quick, that it outpaced the very expansion of the cosmos around it. It sat at the center of a young galaxy, pulling matter in, feeding, glowing, shaping its surroundings. It became a beacon, one of the first cosmic landmarks, a lighthouse in the fog of time. And now, billions of years later, through the eyes of James Webb, we see its ghostly light. If you close your eyes and imagine it, you can almost feel what that must have been like. The early universe, dense and hot, filled with swirling gas and newborn stars. And then, somewhere in that chaos, gravity takes hold, collapses matter inward, and a new kind of object is born, an abyss that bends everything around it. Space stretches, time slows, a singularity forms, invisible, eternal. From that moment onward, the universe will never be the same. The first black holes become the anchors of galaxies, the engines of creation. And their light, or rather, the light of their destruction, begins its endless journey through space, eventually reaching us, billions of years later, whispering of the first darkness. Perhaps that's why Webb's discovery moves us so deeply. It's not just about numbers or data, it's about witnessing the balance of creation. We are seeing how the universe built itself not just from light, but from the tension between light and shadow. We are seeing how the same force that creates stars also births the darkness that swallows them. The cosmos is both destroyer and creator, and black holes are the heart of that duality. When we look at those ancient black holes, we are looking at cosmic power beyond comprehension, gravity so intense that it shapes reality itself. Yet we are also looking at something strangely familiar, because in a way, Black holes are metaphors for our own nature. Just as they hold galaxies together, unseen but essential, there are unseen forces that hold us, gravity of love, of memory, of meaning. We too are shaped by invisible centers, things that pull us, define us, and sometimes consume us. The universe outside mirrors the universe within. Webb's shocking discovery is not just a challenge to science, it's a reminder that creation is not linear. It's not predictable, it's mysterious and alive. It tells us that the universe is capable of doing in hundreds of millions of years what we thought would take billions. It tells us that nature is more inventive than our equations, more daring than our imagination, and maybe, just maybe, these ancient black holes hold answers to questions we haven't yet asked. What lies beyond the event horizon? Is it destruction or transformation? Do black holes erase information, or do they preserve it in ways we can't yet perceive? Some physicists even wonder if black holes could be gateways, bridges to new regions of space-time or even new universes. If so, then the earliest black holes Webb discovered may not just be relics of the past, but portals to understanding existence itself. So when we say that James Webb looked too deep into space and found something shocking, what we truly mean is that it found the universe's greatest secret, that from the very beginning, light and darkness have worked together to build everything we know, that even at the dawn of time, creation had already learned the art of paradox. That in the first breath of existence, the universe whispered both life and death into being, and from that duality, everything arose. Webb's golden mirrors have shown us that black holes are not just the end of things. They are the wombs of galaxies, the cradles of creation, the silent hearts beating at the center of all cosmic beauty. And their discovery so early in time is more than a scientific surprise. It's a message, a revelation from the universe itself, that even in its infancy, creation was already capable of infinity. When James Webb pointed its golden mirrors into the deepest darkness of space, it wasn't just seeing stars, it was seeing the invisible threads that hold the entire universe together. What it found wasn't merely distant galaxies glowing faintly in the night. It was the shape of the unseen, the gravitational skeleton of the cosmos itself. For the first time in human history, we began to glimpse the architecture of the invisible, the silent force that has guided the universe since the very beginning: dark matter. It's strange to think that everything we see of the stars, the planets, the nebulae, the light, makes up less than 5% of the universe. The rest, the overwhelming majority, is dark. Not dark in color, but dark in the truest sense, beyond light, beyond detection, beyond the senses. And yet, without it, nothing would exist. Galaxies wouldn't hold together, stars wouldn't form, even the atoms in your body would never have gathered. Dark matter is the invisible hand of creation, the silent architect shaping all structure in the universe. And through Webb's eyes, for the first time, we're beginning to trace its fingerprints. When Webb took its first deep field image, a breathtaking vista filled with thousands of galaxies, there was something strange about the shapes of light. Some galaxies appeared stretched, curved, or multiplied, their light distorted into rings and arcs. This wasn't an optical illusion. It was the result of a cosmic phenomenon predicted by Einstein himself: gravitational lensing. When light from distant galaxies passes near a massive object, like a cluster of galaxies or a concentration of dark matter, gravity bends the path of that light. Space itself curves, and the distant light follows the curve. The result is one of the most beautiful and haunting effects in all of astrophysics: a natural lens made of gravity, revealing galaxies too faint and far to be seen otherwise. Webb's infrared vision, sharper and deeper than any telescope before it, captured these distortions with exquisite detail. It was like seeing the universe through a veil made of invisible mass. Every arc of light, every stretched galaxy, Every warped halo was telling us something about the dark matter hidden behind it. It was as though the invisible universe had finally cast a shadow we could study. Scientists took these images, these twisted shapes of light, and used them as maps. By studying how much and in what direction the light was bent, they could calculate the distribution of mass in the foreground. What they found was astonishing. The visible galaxies, the bright, glowing clusters of stars, accounted for only a small fraction of the bending. Most of it came from something unseen, something massive, something everywhere. Dark matter was not a theory anymore, it was a presence written into the geometry of light itself. And that's the quiet miracle of Webb's discovery. It has allowed us to see the unseen by observing how it moves the seen. Light, the oldest traveler in existence, carries the fingerprints of everything it's passed through, and dark matter leaves deep impressions. In Webb's images, those impressions become visible arcs of galaxies stretched into crescents, halos of light bending around emptiness, entire regions of space magnified like a cosmic mirror. When you look at one of Webb's deep field images, you're not just seeing galaxies. You're seeing the curvature of reality, space bending under invisible weight. You're seeing how dark matter weaves a web that connects everything from the smallest star to the largest cluster of galaxies. That's why scientists call it the cosmic web, a vast, interconnected network of filaments stretching across billions of light years. Every galaxy, every cluster, sits like a bead on those filaments. Dark matter is the thread, invisible but essential, holding the tapestry of existence together. It's humbling, isn't it? To realize that the universe we can see, the brilliant fireworks of galaxies, the glowing birthplaces of stars, is only a thin surface layer floating on an invisible ocean. Beneath that surface, dark matter shapes everything quietly and without light, like an unseen sculptor working in the shadows. Webb's deep field views reveal that this dark scaffolding existed almost from the very beginning. Even in the earliest galaxies, the pull of dark matter is evident. The structure of the cosmos was already defined by something we cannot touch or see, but what is dark matter? That question has haunted physics for nearly a century. We know it's there because of its gravity, because of how it bends light, how it holds galaxies together. But we don't know what it's made of. It doesn't emit light, absorb it, or reflect it. It doesn't interact with ordinary matter in any known way except through gravity.
The James
Some
Webb Space
scientists think it's made of
Telescope's
exotic
detection of water
particles,
vapor in the
WIMPs,
atmosphere
weakly
of an
interacting
exoplanet
massive
only
particles
26 light
that pass right
years
through
away
us
belongs
every
to this
second by the
category of
trillions.
world-changing
Others think it might
milestones.
be
To
actions
call it
or some
historic
other
is not an
particle we haven't
exaggeration.
even
It is the
imagined yet.
continuation of
Some
a legacy
more
of
radical
human
ideas
curiosity,
suggest it
stretching
could be
from
the
the first time
gravitational
ancient people
echo of
looked
other
at the night
dimensions,
sky
or
to
the
the moment
shadow of
scientists
quantum
launched
fields
JWST
woven
into
into
orbit.
space-time
This
itself.
discovery is not
Whatever
just
it
about
is,
data
it's
on a
not
screen.
nothing.
It is about
It's
our
the invisible
identity as
majority of the
explorers, our
universe,
destiny as
the
seekers.
silent framework upon which everything hangs. Without dark matter, galaxies would fly apart, stars would scatter, and the universe would be a cloud of unbound gas. Dark matter is the glue that holds the cosmos together, and Webb, by peering so deep into time, is letting us watch that glue at work. In one of Webb's most iconic images, a massive galaxy cluster acts as a gravitational lens, bending and magnifying the light of galaxies behind it. Some of those background galaxies appear multiple times in the same frame, like ghosts reflected in mirrors of curved space. The arcs of light form patterns that trace the dark matter's invisible contours. When scientists model the mass distribution that could create those shapes, they find enormous amounts of unseen matter, sometimes 10 times more than all the visible stars combined. In that image, you're not just looking at distant galaxies, you're looking at the shadow of the invisible. The lensing is the whisper of dark matter, the universe's way of saying, I'm here even if you can't see me. What makes Webb unique is that its infrared vision allows it to peer through cosmic dust, the kind that hides young galaxies from optical telescopes. That means it can see gravitational lensing effects farther and clearer than ever before. It can see galaxies behind galaxies, light bending not just once, but multiple times through layers of invisible structure. The deeper Webb looks, the more it reveals how vast and intricate the dark universe truly is. Think about that for a moment. The light from those distant galaxies has traveled for over 13 billion years. Along the way, it's been stretched, bent, and magnified by the invisible hands of dark matter. Every twist in that light's path is a clue, a message written in gravity, and Webb is decoding it. Piece by piece, lens by lens, we're beginning to build a map of the invisible universe, a cartography of the unseen. And as the map grows, something profound becomes clear. The structure of the universe, its shape, its form, its beauty, is not random. It's patterned, it's intentional. The filaments of dark matter that Webb helps us trace are like the veins of a living organism, carrying the flow of cosmic creation. Galaxies form where these filaments intersect, like drops condensing at the nodes of a web. The universe is not chaos, it's choreography. Every galaxy's motion, every cluster's formation, follows the rhythm of the invisible. It's strange to feel such wonder for something we cannot see. But that's what makes dark matter so poetic. It reminds us that not everything real must be visible. That some of the most powerful forces in existence work quietly, unseen, holding everything in place. It's the same truth that echoes through human life, that love, gravity, faith, and meaning are all invisible, yet everything collapses without them. Webb, in a way, isn't just showing us the structure of the cosmos, it's teaching us something about our own nature. The universe we live in is mostly hidden. The same light that lets us see also blinds us to what lies beneath. And perhaps that's fitting, because if everything were visible, there would be no mystery left, no wonder to pursue. Dark matter is the universe's greatest secret, and Webb is our first step toward uncovering it. As more data pours in, scientists are finding something even more mysterious. Dark matter might not be distributed exactly as we expect. In some regions, galaxies seem to move in ways that don't perfectly match our models. It's as though dark matter isn't just passive scaffolding, it may have a story of its own. Some even wonder if dark matter can clump, interact, or even decay in ways we don't yet understand. Webb's higher resolution lensing data could hold the answers. Every curved arc of light, every subtle distortion, is a clue in the greatest cosmic detective story ever told. There's something almost spiritual about this pursuit. To study dark matter is to study the unseen will of the universe, the structure that gives birth to all things. And the more we uncover, the more it feels like the cosmos itself is alive, a vast, interconnected being woven from both visible and invisible threads. Light gives it a face, dark matter gives it a soul. When Webb sends back an image filled with glowing galaxies and faint red arcs, it's easy to be mesmerized by the beauty of it. But hidden in that beauty is the humbling truth that we are surrounded by mystery, that what we can see is only the smallest fraction of what truly exists. That everything luminous, stars, planets, people, floats in an invisible sea. Dark matter doesn't shine, but it sculpts. It doesn't speak, but it leaves echoes. And as Webb's golden mirrors gaze deeper into time, those echoes are finally becoming visible. The universe, once thought empty between galaxies, is now revealed as full of gravity, structure, and meaning. It's almost poetic that our greatest tool for studying the invisible is built from the visible: gold mirrors, silicon chips, and human imagination. Webb itself is made of matter shaped by dark matter's cosmic design. Without dark matter, there would be no galaxies, no Earth, no telescope, no eyes to look back. In that sense, Webb's discovery is not just scientific, it's existential. It's the universe looking at itself, seeing its own invisible reflection through the light it bends. Maybe that's what makes this discovery so moving. The deeper Webb looks into the darkness, the more it finds connection, the realization that everything, everywhere, is linked by something unseen. The galaxies in Webb's images are not isolated islands, they are parts of a grander whole, bound by invisible gravity across billions of light years. The same force that binds stars to galaxies binds galaxies to each other and binds us, too, to the universe that made us. So yes, when James Webb looked too deep into space, it found something shocking. It found that the true structure of the cosmos is not made of light, but of shadow. That the universe is not held together by what we see, but by what we cannot. It found that the most powerful force in existence is invisible, and yet it shapes everything we love, everything we know, everything we are. And maybe that's the lesson hidden in the stars, that what is unseen is not unimportant, that the quiet forces, whether cosmic or human, are the ones that truly hold the world together. When the James Webb Space Telescope opened its golden eyes to the universe, humanity saw something that changed not just astronomy, but the very way we see ourselves. For generations, we've looked up at the night sky with a quiet question pulsing inside us. Where do we come from? Why are we here? Are we alone? And with every new telescope, every discovery, we've peeled back a little more of the mystery. But when Webb looked deeper than anything before, into time itself, the answers it found were not simple, they were transformative. The universe, in its silence, began to whisper truths that redefined what it means to be human. It's strange how a machine made of metal, mirrors, and mathematics could make us feel so profoundly alive. But that's what Webb did. It turned its gaze toward the beginning of time, to galaxies formed just a few 100 million years after the Big Bang, and in that ancient light, it showed us the story of creation, not written in myth or poetry, but in photons traveling for 6 billion years. Each beam of light Webb caught had been on a journey longer than all of human history. That light left its home before the Earth even existed. It passed through darkness, through collisions, through endless stretches of cold vacuum, and finally it reached the golden mirrors orbiting one small planet, and for the first time it was seen. Think about that for a moment. Light older than our world itself, older than the sun, touching a human-made instrument, as if the universe had been waiting for someone to finally open their eyes wide enough to see it. In that moment, the distance between human and cosmic vanished. We weren't observers anymore. We were participants in a story far older and grander than we ever imagined. When Webb captured its first deep field image, the world fell silent for a heartbeat. That image, filled with thousands of galaxies, each containing billions of stars, each star perhaps with its own worlds, looked like a portal into infinity. It was a reminder that our entire existence, every life, every story, every triumph and sorrow, happens in a corner of one galaxy among uncountable others. And yet, instead of making us feel small, it did the opposite. It made us feel connected, as if we were part of a grand design too vast for the human mind to fully hold. Because when you stare into that deep field, you realize that the atoms in your body were forged in those same stars. The carbon in your cells, the calcium in your bones, the iron in your blood, all of it was once inside the hearts of ancient suns that lived, died, and scattered their elements into space. You are quite literally the universe looking back at itself. You are stardust that learned to wonder. And Webb is the mirror that allowed the cosmos to see its own reflection. For centuries, humanity looked up and imagined gods among the stars. But now, through Webb's eyes, we see that creation itself is godlike, vast, patient, and filled with an intelligence far deeper than our own. Every galaxy Webb captures, every spiral of light, is a verse in the cosmic symphony that has been playing since time began. And we small, fragile, temporary beings are the only instruments capable of hearing it. That's the paradox Webb revealed. The more we learn about the universe's immensity, the more we realize our own importance within it. Not because we are at the center, but because we are aware. Out of all the silence, all the void, consciousness arose. The universe spent 8 billion years creating eyes that could see it, minds that could question it, hearts that could feel awe in its presence. In that sense, humanity is not an accident. We are the universe's awakening its ability to know itself. Every new discovery Webb sends back feels like a message written across the stars. When it detected the faint signatures of water vapor on distant exoplanets, it wasn't just data. It was possibility. It was the idea that somewhere out there, under a different sun, oceans might shimmer, clouds might drift, and perhaps life might breathe. For the first time, we're no longer asking if life could exist elsewhere. We're beginning to look for it directly. Webb is not just a telescope. It's humanity's extended vision, reaching into the infinite to find reflections of ourselves. But with that expansion of vision comes humility. We once believed the Earth was the center of the universe. Then we learned it wasn't. We believed our sun was unique. Then we discovered billions like it. Now we're realizing that even our galaxy is just one among trillions. Each discovery Webb makes pulls us further from the illusion of centrality, and yet, paradoxically, brings us closer to meaning. Because meaning isn't found in being the center, it's found in connection, in knowing we are part of something immense, intricate, and beautifully alive. When Webb peers into ancient galaxies, it's looking at the universe as it was when it was still young, still finding its shape. Those galaxies are the ancestors of everything we see today. The same physical laws that shaped them, gravity, light, time, shaped us. In their glow, we see the first stars forming, the first atoms gathering, the first whispers of cosmic structure. It's the story of everything, the slow unfolding of existence itself, and that realization changes something deep inside you. It reshapes the question from who are we in the universe to what is the universe within us, because it's not just out there. The same forces that curve space-time and ignite suns flow through your own body. Every heartbeat echoes the same rhythm as pulsars spinning in distant galaxies. Every breath is an exchange of ancient matter that once belonged to stars. You are not separate from the cosmos. You are an expression of it, a momentary configuration of starlight and thought. Webb's discoveries remind us that our search for meaning was never about finding something outside of ourselves. It was about recognizing that we already belong. When we gaze into those deep, dark regions of space, we are, in truth, looking inward. The universe is not a distant mystery to solve, it's a home to remember. And yet, there's something even deeper. As Webb reveals more of the cosmic past, it also confronts us with the fragility of existence. The galaxies we see, majestic,
the James Webb
immense,
Space
eternal,
Telescope's
seeming,
detection of
are
water
themselves
vapor in the
temporary,
atmosphere
stars
of an
die,
exoplanet
worlds
only
are
26
consumed.
light
Even
years
galaxies
away belongs to
collide
this
and merge.
category of
The
world
universe is not
changing
static.
milestones.
It's a
To
constant
call it
dance of
historic is
creation
not
and
an
destruction.
exaggeration.
That
It is the
realization
continuation of a
forces us to
legacy of
see
human
life
curiosity,
differently.
stretching
It
from the
makes
first
every
time ancient
sunrise,
people
every
looked at the night
heartbeat,
sky
every
to the
act
moment
of
scientists
kindness feel
launched
sacred,
JWST into
because
orbit.
in a universe
This
so
discovery is
vast
not
and
just about
impermanent,
data on a
the
screen.
miracle is
It is
not
about
that we
our
exist,
identity as
but that we
explorers,
can
our
love,
destiny as
dream,
seekers.
and create. Within it, that's what Webb's images really show, not just cosmic history, but cosmic perspective. They remind us that time is not a straight line, but a living continuum. When Webb looks at a galaxy 13 billion light years away, it's looking at a moment that still exists in the fabric of space-time. The past is not gone, it's still shining. Every photon Webb catches is a time traveler, carrying a message from creation itself. We live surrounded by ancient light, and now, for the first time, we can read it, and reading it changes us. It reminds us that progress, knowledge, and wonder are humanity's true inheritance. That our curiosity, this unstoppable urge to explore, to understand, is not a weakness, but a signature of who we are. Webb stands as proof that even in a small corner of a small galaxy, life can rise from dust and dare to look across eternity. It's easy to look at Webb's breathtaking images and feel small, but maybe smallness isn't an insult, maybe it's a gift. Because to be small and still capable of awe is the greatest miracle of all. To stand beneath the night sky, knowing how vast it is, and still feel that it matters, that you matter, that's the kind of meaning no other creature in the known universe has yet achieved. Webb didn't just show us the cosmos, it showed us the scope of the human spirit. When the first images were released, people across the world wept. Not because of science alone, but because of what those images represented, a species united, however briefly, in wonder. Borders, languages, religions, none of it mattered when we were staring into infinity together. For a fleeting moment, humanity remembered that we are one tribe, one story, one fragile spark of awareness floating in a sea of stars. And perhaps that's the real discovery Webb has given us, not what's out there, but what's within us. Because as we gaze further, we begin to understand something profound. We are temporary, but the beauty we create lasts. The light Webb sees today will outlive us by billions of years, traveling onward long after we are gone. Somewhere, in another corner of the cosmos, another civilization, perhaps millions of years from now, might detect the faint radio echoes of our existence. And they too will wonder who we were, what we believed, what we dreamed. The universe doesn't measure greatness in size or power. It measures it in consciousness, in awareness. Webb's discoveries have shown us that the rarest thing in existence is not stars or galaxies, it's beings who can look at them and feel wonder. That is our gift, that is our purpose, to see, to feel, to remember, to keep searching, even knowing how small we are. And maybe that's what the universe has been trying to tell us all along, that we are not meant to conquer the cosmos, we are meant to understand it, to cherish it, to protect it. That intelligence is not domination, but harmony, that the more we learn, the more reverent we should become. Webb's golden mirrors reflect not only light, but humility, a quiet acknowledgement that we are guests in a universe that existed long before us, and will continue long after. Yet, within that humility, there is strength, because knowing how vast the universe is doesn't make life meaningless, it makes it miraculous. Every act of kindness, every dream pursued, every life lived with love becomes infinite in its own way. We are the universe's brief but brilliant experiment in self-awareness, and in Webb's gaze, that awareness burns brighter than any star. So when we look at those images, at galaxies colliding, at light older than life, at beauty beyond comprehension, we're not just seeing the universe's past. We're seeing our own potential, we're seeing what humanity becomes when we choose curiosity over fear, creation over destruction, wonder over apathy. Webb is not just a telescope, it's a mirror held up to our collective soul, and what it shows is extraordinary. It shows a species that began in darkness, learned to make fire, looked up, and never stopped reaching. It shows that even in the vast, silent expanse of space, life found a way to look back, to give the cosmos eyes, voice, and meaning. Webb's discoveries remind us that we are not lost in the universe. We are the universe, awake, aware, and still unfolding. And maybe that's the final revelation, that the purpose of humanity is not to find answers, but to keep asking the questions that light the darkness. Because in every question lies the same spark that ignited the first stars, the desire to be more, to understand more, to become more. So when you look at the night sky tonight, remember this: every point of light you see is not just a star, it's a story. Some are stories still being written, some ended billions of years ago, and now with James Webb, we are the storytellers of the cosmos, chroniclers of the infinite. We have finally learned to listen to the universe's oldest song, and in its echo, we have found ourselves.